welcome everyone. Thanks for joining us today. If we haven't met or been introduced, my name is Amanda Henley. I'm your host for today's virtual user group for Db2. I am managing editor over at Planet Mainframe. So thanks for joining us. We've got a great session for you today on a topic I'm really excited to hear about because I love to hear about anything related to AI. And after seeing a session a couple weeks ago about AI and mainframe, frankly, this cross section, and this is an exciting time with the new Z17 release. I think there's just some really cool stuff coming down the pipeline, and Keziah is here to tell us about it. So let me give you a few announcements. First of all, there's a partnership opportunity to be a virtual user group sponsor. You can reach out to me if sponsoring one of our user groups is of interest. At Planet Mainframe, I just wanted to give a shout out to our influential mainframers that we just celebrated all month in April. And all those profiles are up online. We just did a recap report last week. So you can go check out all of those. And then we have some other fresh content like a release of a new research report on the scene from Pop-Up Mainframe. And as always, Planet Mainframe is your source for event listings, jobs, news, the Arcadi Navigator, and the Cheryl Watson tuning letter. Which brings me to letting you know that today is the latest release of the Cheryl Watson tuning letter. It will be out at in 25 minutes. We should get the latest drop on that. If you're not already a subscriber, you can subscribe online. It's pretty quick and easy, but that is exciting for us. It only happens 4 times a year, so. And then we were talking about it a few minutes ago, but we are going to be at the IDUG conference in Atlanta, where I am based. So please come see me in a couple weeks at the IDUG conference here, beginning of June. And let's see, I should remind you that we have an exit survey after today's session. And it's real quick, 2 questions when you're leaving. For Q&A today, Keziah, if it's okay, we'll hold questions until the presentation is over or drop them in a chat. You can leave them there. If it's something that it's like, hold up, I lost you, like maybe just say, hold up, I lost you, in chat. But now let's get to our session. So we're here for AI and Db2 for ZOS, a brief overview. And our presenter today is Keziah Knopp. She is a data and AI on Z specialist based out of New York, where she covers AI, data and AI solutions. She has previously been a Db2 for ZOS specialist, and you've probably met her at conferences like Share or GSUK, or she's a returning speaker of this user group. So thank you so much for joining us today.
Thank you, Amanda. Happy to be here. Let me go ahead and start sharing. Can you see my screen okay? Great. So I have 2 monitors up, so I'll be kind of moving between the 2 of them. Just so you know, my background is the new Z17 that just came out. There's a lot of good AI integration with the Z17. However, today I'm going to be focused on Db2 for ZOS. So as Amanda mentioned, my background is really in Db2 for ZOS. I was in IBM's Washington Systems Center, focused on that entirely. And I recently just moved to the financial services market for IBM, mostly based out of the Northeast, but covering several parts of the US territory. So anything that is related to data and AI on Z is now in my portfolio. And I actually decided to present this before I changed jobs. So this is very much in my wheelhouse, both with Db2 and with AI. This is one of my favorite topics to talk about because before I worked at IBM, I studied computer engineering for my undergrad, and I actually wrote my undergrad thesis on parts of AI. And that meant I had to define what AI was. And this was before the AI revolution that's been happening over the last few years. I was an undergrad before that started. So This is kind of my take on where we're seeing AI and DB2 for ZOS right now. So what we'll be covering in the context of this presentation today is I'm going to start with context. So since this is focused on DB2 for ZOS, I am going to start with DB2 for ZOS. There is one slide that I have on it, and if you are a DB2 person or a DBA or anything like that, you will know that one slide does not do DB2 justice. But when I give a presentation, I really like to set a foundation. So I'm going to be setting a foundation for you, both with DB2 for ZOS and with AI. So AI, I know, is a buzzword. It is a hot topic. It is covered across almost any presentation that you go to today, whether that is IBM associated or not, or mainframe associated or not. So I'm going to talk about a little bit of my personal background with how I define AI and then move into AI in DB2 and in the mainframe context. So moving forward from there, there's about 3 categories of where I see AI infused into DB2. Trust me, there's a lot more AI outside of DB2 and in the mainframe, but this is what we're going to be focusing on for the context of this presentation. DB2Z AI, or DB2 AI for ZOS. This is a separately orderable, separately charged product that is allowing you to infuse AI or to use AI to improve your DB2 for ZOS database and environment. So I'm going to talk about what that product does and how that incorporates AI into your mainframe environment. Again, that's a separately orderable product from DB2 for ZOS. But that often gets confused when you mention anything related to AI and DB2. So SQL Data Insights is the next category that I'm going to talk about. And both with DB2Z AI and SQL Data Insights, I will tell you what the product is and what it does and what these features are, and I'll show you a few screenshots of what that looks like when you're interacting with that piece. So SQL Data Insights is a feature of DB2. It is pretty much included in DB2 version 13. There's a few extra installs that you need to do to have access to it, but that allows you to use these AI insights as SQL queries. So since DB2 is your database and you're calling SQL on it, SQL Data Insights provides now 4 new queries that are an AI query that allow you to look at your data in a different way. And then this third category here, AI built into DB213. So all the way through function level 507, which just came out, there's a set of enhancements that have been incorporated into version 13 of DB2 that are AI, let's call it in the AI category. Some of that is machine learning, some of that is deep learning, some of that is AI. So we'll talk about what each of those little pieces does in version 13. And again, as Amanda said, please feel free to drop stuff in the chat and we'll take questions at the end. And I'm going to pause for water throughout. My allergy season is really rampant in New York City right now. Okay. So DB2 for ZOS. This is a subsystem of ZOS. So if you're a DB2 person, hopefully this looks familiar. And if you are not, you are a mainframe person, probably because you're here. I'm assuming a little bit of that. And so DB2 is a subsystem of ZOS. It is the main relational database system inside of ZOS. The other main database is IMS. And DB2 has these 4 or 5 main address spaces that are listed here. There we go. So we have our DBM1. This is the database address space, the first one, and this is what sets up DB2 from the beginning. It provides most of the database services. MSTR is the master. This provides a lot of the system functions that are available in DB2. We also have IRLM. This is where the locking occurs inside of DB2 serialization method of saying who gets what resources and in what priority. The DIST address space is the distributed, and this controls the remote access inside and into DB2. And then we also have WLM, which is your workload manager. This really brings in WLM with DB2 to give priority to certain incoming work, to provide a way to effectively and efficiently move around resources within DB2. And here at the bottom, we have these three areas of DB2. So you have your catalog and directory. So that is saying, what do we have here in DB2? What are the table spaces? What are the directories? What are all of the things? That's all listed in the catalog and directory. And we have our user tables and our indexes. So that's where all of the bread and butter, the meat and potatoes is in DB2, where our actual data is, our table spaces, our tables, our indexes, our index spaces, all of that good stuff. And then we also have a log. This recovery log includes active and archive logs in terms of DB2. So it keeps track of everything that the system does, everything that's happened in the system, and can be used for recovery, for disaster recovery, for anything like that, or just to make sure that you know what's going on in your system and to know what user is doing which thing. Okay, yep. So data sets include your system data, your user data, and your DB2 recovery log. And when we are taking a look at a lot of these AI components in DB2, we're going to be mostly focused on what data is inside of DB2 and then how do you take advantage of that data in the best way possible. Okay, so this brings me now to AI. This is augmented or artificial intelligence. It's funny, I gave this presentation in person a few weeks ago, and I asked the audience, who was full of mainframe people, DB2 people, DBAs. I was like, can any of you like really give me a definition of AI? I was expecting somebody to raise their hand, or at least a couple of people, and no one did. And I know that that's like a small sample set, but it was an indication to me that we talk so much about AI right now, and it's actually pretty hard to define AI. It's there's a lot of different definitions out there depending on where you look. Let's see. So this brings me to what is AI? And there's a few different categories that I'm going to walk through of where AI is, but when I was looking at it with like my personal background, so this is not an IBM part of me saying this, artificial intelligence was defined as something that could get to a human level of intelligence, which we're like not quite there. There is a lot of AI that is a combination of machine learning and deep learning, which is saying, okay, hey, we have our data, or I'm training a model and I'm training it to learn what to do next, what to predict, or what to assess, or things like that. And so AI is this form of let's see what we have, let's see what's here, and then let's go forward. Let's make decisions, let's predict what's going to happen, let's do an analysis. And it does often provide, or it can provide, a deeper level of insight as to what might be going on with the given scenario than what I could understand, or than what a human could understand, depending on what the situation is. I know that I work with a lot of people who have been in the mainframe for decades, and to me, their knowledge is irreplaceable. And there's a lot of knowledge that's being infused into AI, like, for example, all the Watson X stuff that's available with IBM right now is a lot of like, I'm looking for this definition or this acronym or what this thing does. So there's a lot of product knowledge that's brought in there. But in terms of how we work as people, it's a very different flavor. And I'm sure that all of you have interacted with AI to some extent, and you know that there's a little bit of a difference. So I'm going to start with Pop AI. So whenever I talk about AI, it's so funny because it's now vocabulary for people who don't even work in tech. And so when I say pop AI, it's kind of like what is actually popular in media and in conversation today, regardless of whether you work in tech or not. So this can be your Chat GPT, your Claude, your Watson X Assistant for Z, for example, or your AI image generators. I know, in more COVID times, we're in late COVID, there was a big rush of people like using AI image generators to create different pictures of what they would look like and different outfits and things like that. So this is all this like pop AI. This is a lot of generative AI. It creates new content based on content that it knows or that already exists. Agentic AI, this is another one that kind of falls under this new category. This is what focuses on making decisions and taking actions based on given knowledge. So there is a level of agency with this AI. So some examples of this could be Waymo, those are the self-driving cars, or Boston Dynamic Robotics, that's that yellow thing over there. So if you're in any of this, you might recognize these. And that's a lot of like doing a thing, making a decision, making a choice going forward. Here are the other categories of AI that there's plenty more, but this is kind of what I've defined for this scope right now. There is traditional AI, and this is where you select data to train. It will create a model, it will identify patterns, insights, certain relationships between data that may not have been super obvious before. Traditional AI. So this moves then into predictive AI. So predictive AI will take traditional AI as a step further and predict things that may happen or might be likely to happen in the future. What trends we're seeing, what analysis could come up, things like that. And finally, this last one is where I'm going to start and highlight here is this idea of operational AI. This is where we bring in commercial and enterprise AI. So this is what's targeted at improving efficiency, making things more productive, more effective. Let's automate tasks. Let's enhance workflows. This is a lot of real-time data processing or near real-time, depending on where you are in that scope. This is a lot of AI ops, so anything operational, anything automated, anything like that, that's especially at a commercial or an enterprise scale. So when we're talking about DB2 for ZOS, this is really kind of the focus area, although things that we're talking about today will bring in stuff both from traditional AI and predictive AI. And a little bit of pop AI, depending on which one we're talking about here. So operational AI in DB2 for ZOS. This allows you to do more with less. Ultimately, the goal of AI is to make things more optimal, more effective, more efficient. So we can optimize operational costs with and as data and workloads are growing. And hopefully this makes our jobs easier, relieving pressure that may have been felt by DBAs or managers or app developers saying, oh, I can get AI to do this. And I also want to highlight here that this does not necessarily mean replacing a job or a person, but enhancing what is already there. So I know for me and a few other people that I've talked with who are in a more technical position than I am, so DBA or an app developer and things like that, it's this idea of being able to bring AI in to help you do your job even better, to make it more efficient, to make it easier. All of the tedious things that I have to do or that we have to do, being able to automate that is this idea of operational AI, especially within my job and especially at a larger scale. And reducing the high learning curve. I know that this is a really, what's the word I'm looking for? Not sticky, but this is a really poignant topic in mainframes because there is this skills gap. Like I said, I work with people who have been in the mainframe for decades, and I am not quite yet at a decade. We're getting closer though. But there is this gap, and I see it in my job. I see it when I talk to my customers, and being able to close that experiential and knowledge gap. I mean, in my personal experience and in my opinion, AI will not make up for the experiences that I have when I'm troubleshooting or with my customers, but there is a level of like help that can happen with AI to make my job easier and to maybe make that gap easier to close or faster to close. When I started in the mainframe, they kind of gave me this idea that it would take at least 5 years to kind of get over that learning curve. And I would say that that's probably true. So hopefully making sure that we can like bring people in to this world and have them learn in the best way possible. And ultimately, we want to simplify these really complex environments. The more that I learn about DB2, the less I know. There's so much behind that database. It is very complex. And being able to gain insights into different parts of DB2 into this really complex overall mainframe environment, that is so helpful. And so this is where operational AI can kind of come into play with DB2. Okay, so DB2 AI for COS, also known as DB2Z AI. This will collect operational data, DB2 data, and then leverage AI to improve DB2 performance and resilience. And I want to clarify here. So when we're talking about DB2, we have that user data that we looked at the beginning in those user and table spaces and all of that. And then we also have data about DB2, how DB2 is performing, what its settings are, how each part of the subsystem works. So there's this like metadata layer of that. And so DB2ZAI will collect that metadata about how DB2 is performing and then use that to better optimize the overall subsystem. And it's broken down into three components. The first one is SQL optimization. I'm going to go into a little bit more detail on each of these in the next few slides. This one, the idea of this is to reduce CPU consumption. Depending on what your job is here, I don't know if you've ever seen a SQL query that maybe could have been written better, or if there was somehow opportunity for improvement in the SQL queries that are associated with your organization. I know some of my customers come to me with that, saying, I know that this could be better. Writing good SQL is a skill, turns out. So being able to reduce CPU consumption associated with writing SQL queries. The second section here is system assessment. This is based on improving productivity, and that means less time spent analyzing data, more time spent on finding solutions. But really, we're assessing how your system is performing. What could be better in terms of the setup of this to then say, okay, how could we set up the environment or the subsystem better to improve productivity overall? And then distributed connection control. So this is protecting critical resources. This is incoming work, incoming connections, and this can be somewhere between preventing issues from occurring, like a flood of connections, which happens often, surprisingly, or not surprisingly, and then being able to work with the incoming connections, work with the incoming work, and say, how do we associate this with the resources that it needs and protecting the resources from not being used up. I know that I have recently worked on a client situation where they had incoming work. It was using all of their DB2 like member resources, and then that would not, it would basically say, this is being used 100%, let's move to the next member. That member would go to 0, the next one would go to 100%. And being able to say, okay, actually we want to parallelize this work. We have incoming work and we don't want one member to be at 100% and the next member to be at 0%. We want to be able to balance the workload that's coming in. So this DB2Z AI, on the left here, we have our data collection, and that moves into learning and optimization. So this is based off of the subsystem that it is associated with. So if you have DB2Z AI in your environment, it is based on your environment, not based on this generalized idea of overall subsystem. I mean, there is best practice and there's recommendations. So taking that into account, but also especially taking into account your exact environment. Okay, SQL optimization, this part. This is really about choosing the best access paths. And this is saying, okay, what is the best access path to find what we're looking for with this query? So SQL optimization in DB2Z AI will be able to predict what a likely host variable will be, predict rows that will be fetched, optimize for the best runtime, and then detect and resolve any regression that may come up. So ultimately, we are reducing costs by improving performance. So if we can improve performance of DB2, then we can reduce the cost overall from your CPU cycles and hopefully reduce that tuning activity work that might be associated with figuring out the best optimal SQL and access path and really stabilize that access path. I know that when our customers are switching DB2 versions and upgrading and looking at binding or rebinding packages at a certain level, there's a lot of effort that goes into making sure that the access paths work well and are stabilized. So this SQL optimization part of DB2 AI for ZOS will be able to do that based off of what's available in your environment. System assessment. Identify DB2 system tuning opportunities. So when I was working in the Washington System Center at IBM, we did a lot of health checks. And this is where we would come in and look at your system and see how it's performing and see what areas of improvement are available. And I was entirely focused on the DB2 portion of those. We did it, you could have it for any subsystem in ZOS. And this brings in this idea of system tuning for your DB2. Saying, okay, let's look at what your ZPARMs are set to, what your buffer pool and group buffer pool settings are set to, how your data sharing environment is set up, all of that stuff to say, okay, here's how it's set up, and here is a suggestion or a recommendation on some potential tuning opportunities to make this even better. And so you don't need that really deep technical knowledge if you don't have it. That would otherwise be important in doing that setup for those tuning opportunities. So this will learn what is normal, build a system assessment report so you can go through and read what's going on, and then look at the actionable recommendations and then correlate based on metrics. So then it will say, here's probably why this is happening to identify this root cause analysis of what you're seeing in your system. This is the part where I would say, if you're a DB2 person, do you know if your DB2 is set up as best as it possibly could be? Because this is what it will bring in when you're looking at DB2. The third part of this is distributed connection control. And this part of DB2ZAI will establish these remote connections and thread control coming in through profiles. So if you are using profiles or system profile monitoring, that's the profile table and the profile attributes table, which I highly recommend. That is one of my other favorite topics to talk about. This one works synergetically with that. And you have a lot of granularity depending on what your system is set up as, the granularity to be able to say, I want something different for these applications or these user IDs or this particular location that's coming in and bringing in work. With this part of DB2ZAI, you can also create alerts for when remote connections exceed the threshold. You can look at visualization and charts and graphs based off of what's coming into your system, so you get this actual picture of what's going on. And this way you can avoid any system impact from a large number of connections coming into the system. It will also provide you with best practices that are available. Okay, so here are some screenshots for DB2ZAI. So in this particular one, we are looking at group buffer pool write failed at the primary location. I know there's a lot of text here, but I really just want to highlight, okay, so in this first bar here, this is a category buffer pool. And you'll see the priority, that's a red mark. Okay, let me draw attention to that. Here's when it happened and what we're looking at. And this first recommendation, a number of write failures to the primary group buffer pool have occurred. The system health checks that I mentioned before when I was doing them in the WSC, I would look at, have you had any write failures? Ideally, that number is 0. And so if there are any write failures that have occurred, that is a clear indication that there is an area of improvement, that something could be changed. So this is something that is directly related to the work that I do if I'm looking at someone's system to say, is this performing as it should be? If there are any write failures, especially due to group buffer pools, that's something to look at. And so this will tell you, okay, this is what I see here. This is what I recommend. The second bullet point or the third bullet point, if it occurs frequency, consider reducing or spreading the overall system activity, decreasing group buffer pool cast out thresholds. That's a really big one. This is some really deep technical DB2 stuff. Overall, I just want to highlight that this gives you these recommendations and brings in a particular point saying, this is what I've noticed. Here's another one. This is around locking and deadlocking. So if you have any deadlocking issues in your DB2 subsystem, DB2 ZAI will also take a look at that. I've definitely talked with customers, multiple customers, about deadlocking, making sure that it does not happen, preventing it from happening, or if it does happen, identifying where it occurred. So locking and deadlocking, super important. I will also cover it here. And again, this plays into, what resources are available, who needs what resources when, and being able to prioritize certain things over others. Because that is how or why deadlock often occurs, is when there's a little bit of missteps with the resources and with the priority of who gets what resources when. This example is the average queue time for DDF. That's your distributed data facility. That's your incoming remote connections. So this would be probably associated with the distributed connection control and saying, okay, here's the average queue time for these types of connections that are coming in. This is particularly highlighting that we're queuing while waiting for a database access thread, DBAT. There is a lot of let's say performance tuning opportunities that are available in DB2 with DBATs. There are a lot of ZPARMs like max DBAT and con DBAT that play into this, and making sure that all of your settings are set up for your DB2 to perform as best as possible, especially with DBATs. That's really important. So this is highlighting, okay, where are we seeing maybe a little bit of a slowdown that could identify potential future issues and prevent them from occurring. And as a side note, if you are interested in any of DB2ZAI, SQL Data Insights, anything like that, we have labs and we have workshops that are available through IBM. So if you are interested, let me know or let your IBM rep know that you are interested in seeing that. Okay, this brings me to SQL Data Insights. This is the idea that we are using AI in SQL functions. So we have DB2, our industry-leading relational database, and we're embedding AI capabilities into these SQL queries. This is my buzzword chart for it. These SQL queries allow you to discover hidden information in your actual data, in your user data in DB2, by overall minimizing complexity of deploying AI into your applications. And this is where I want to bring in those different definitions of AI that we were talking about before. So this is a level of operational AI, as well as some aspects of traditional AI where you are training a model based off of data that you've given it. And both in traditional AI and in predictive AI, this is changing so rapidly. So what I say today will not be true tomorrow. But when that was like really getting started in the last couple of years, 2 years, it was really complex. Like you would have to give it a lot of data. You would also have to retrain it multiple times to be able for it to do different functions, things like that. Again, that's changing very rapidly, but with SQL Data Insights, you train it once and you can do a bunch of different things with it. So overall, This allows you to minimize that complexity with AI coming in. Okay, so it uses a single model over multiple fields, and it also uses zip engines and SIMD cards. So if you have zip engines, this both the training and the execution are available to be run on a zip. Okay, so with SQL Data Insights, we have 4 built-in DB2 functions. The first 3 are available in function level 500. AI similarity. This one will return entities that are most similar to or dissimilar to a particular entity. So you would give it, customer 001. I want to find what customers are similar to this one. AI semantic cluster. This one will return entities that are most similar or dissimilar if you arrange it differently based off of 3 entities. So you would give it, all right, customer 1, customer 57, and customer 93. Let's see between these 3, they might have some relationship between them or some certain characteristics that may not be super obvious. Let's see what is similar to these 3 entities, whatever they might be for your data. And then AI analogy. This is identifying the relationship between 2 different things. So X is to Y as Z is to what? This reminds me most of those like standardized testing questions, if you're familiar with them, like the moon is to Earth as like what is to Jupiter, and Jupiter has a bunch of moons. I realize that none of you probably have data based off of moons around Jupiter, but that's an easy example here. This is just to get your brain flowing. And then finally, AI commonality. This function is available in function level 504 of version 13, and this will return values of a column that are outliers with respect to all of the other rows in a table. So this is finding what is common and what is an outlier overall. Okay, so I have a few examples of these SQL Data Insights functions. So in this one, we're calling AI similarity, and we're calling it based off of v.vendor name. So that's our user.data table, user data table here. And this one will return the top 10 vendors that are most similar to IBM Corporation. So this could be things like Microsoft, Amazon, Oracle, anything that's doing cloud or a large database or something like that. AI semantic cluster. We're giving it 3 things. We're giving it IBM, we're giving it Amazon, and we're giving it Microsoft. So based off of those 3 things, return the most similar ones within what I'm giving it for that semantic cluster. I'm sure you could think of a few that are similar here. Oracle is always my go-to, but anyways, return top 10 vendors that are most similar to that one. This one, we are looking at the relationship. So we're calling AI analogy. We're looking at the relationship between IBM and the USA is similar to Samsung and what service country. And I believe Samsung is based out of Korea or South Korea. So it would probably return that, but it will return the ones that are most similar or most like that analogy and that relationship that we're giving it for the SQL Data Insights function. And then finally, AI commonality. This one, we are giving it a driver's license number, and we're saying return the top 15 driver's license numbers that are outliers with respect to all of the rows in the insurance table. And so this might be saying, okay, we have a driver's license number and we want to see what is common, what is an outlier. This could be helpful for identifying insurance or policy claims or anything like that. So this overall gives an image of what's going on behind the scenes with SQL Data Insights. So I'm going to start over here on the left. We have our user.data table. This is the user data that's inside of DB2. That's the data that's there. This includes your customer ID, a gender, a billing for this. The bottom left is the SQL that we're going to be calling. So we're calling AI similarity on that particular customer ID. And what happens with SQL Data Insights is you will have selected this table to say, hey, I want to train a model on this. The model will be trained outside of DB2. There is a user interface, and I'll show you those screenshots when we get there. And that model training process will generate a vector table, and that's what's shown here on the right. This DSN AI DB, this is a generated vector table, and if you'll see, it kind of extrapolates what's available in the original user data table. So what was a column in the original data table is now a row. So it just really pulls apart what is available from that data to provide a level of deeper information and insight into what's going on in your data. And this generated vector table actually looks like a long string of positive and negative decimal numbers that don't make any sense to me or to most human eyes, I would imagine. So this is really where that AI piece comes into play of I'm calling the SQL query on this generated vector table, on this table, but it's referencing this generated vector table, which is something that is a completely different way of looking at data than what I would be looking at when I'm pulling up a data table inside of DB2. Okay, so here are some use cases for using SQL Data Insights. And this is kind of just to get your brain thinking about where you could possibly use this in your company and in your organization. So for example, a credit card company could use this to identify credit card rewards where participants are gaming the system. When I first learned about this potential use case from an actual credit card company that is one of our customers, I thought that's what you wanted to do with credit cards. Like, oh, I'm using this credit card to pay off this other one, so I get more rewards over here. Turns out credit card companies don't want you doing that. They want all of your business on their credit card and not on other ones. So this would be a way to say, okay, now that I've identified which participants might be gaming the system, maybe I can send them an advertisement or bring them back to use my credit card and not the other ones. The government, you can search for tax cheats or tax fraud. I know that last month was turning in your taxes. I will not condone tax fraud like I did gaming a credit card system. But this would allow a government to find out, let's say we have a known tax fraud case. Let's see where other ones might be as well. Sales, and this could be anything across the board. But let's say we have a retail example. We might look for customers based on similar buying patterns. So this could be based on certain demographics, like gender or age or interest of like where I shop. Maybe Amanda and I buy clothes from a similar store, but maybe that's completely different from where you would buy clothes to go to work. So identifying patterns that we might see in trends from our customer data and saying, okay, where are our customers? What is our customer churn like? And then can we predict new products to like of sales to existing customers, which customers might like which product or which color or which thing overall? Even if you're not in retail, you could say, okay, I have sales for whatever it is that my company is working for. And can I identify which customers want which things? What is available and what will make sense going forward? SQL Data Insights. So this is software and hardware requirements that are available for it. So this is available in DB2 version 13. And there is a separate user interface for SQL and for training services. This is a separately orderable, so there's a different FMID that's listed there for this, but this is a no charge feature of version 13. So it's incorporated, but there is a separate component for that interface in this training services. This runs on Z OS 2.4 and up, and you do need to install 3 IBM neural network libraries for this, and that is where a lot of that AI comes into play. And it also uses ZEC 12 cards and up, and anything on a Z14 or higher. That Open Blast library is that binary linear algebra subprogram. So that's where all of the math is for using these AI programs. And just to reiterate, both the training and the execution is zip eligible. Okay, my Zoom box disappeared. So I'm going to trust that everything is fine as I'm going through this. But Amanda, please let me know if something changes. Okay, great.
It looks
So,
fine.
okay, great. Uh, Here's an example where we have our customer 001, and we want to find customers that are similar to this one. So we might write AI similarity on customer 001, and we want to figure out what is most similar and have them descending. So with SQL Data Insights, you will get a similarity score, or you will get a score for whatever query you run as to what is most similar and to what is least similar. And these values are between 0 and 1 decimal numbers. So the higher it is to 1, the more similar it is. So in this example, we have our customer 001, who's a male, not a senior citizen, does have a phone service line, and does mail a check. So if you'll notice in this example, this is pretty obvious what is similar and what's not similar. But theoretically, in a much more complex environment, this might not be super obvious. So this is where you can figure out what is similar and what is dissimilar when you're calling SQL Data Insights functions with this. Okay. SQL Data Insights can be used with any way that you normally call SQL. There is this Data Insights user interface, and I'll show you a couple of screenshots here shortly about what that looks like. If you use SQL with QMF or Spoofy or a batch workload or your remote access for JDBC, ODBC, DRDA, any third-party applications, all of this should work with SQL Data Insights. So whatever you're using to call SQL now that accesses DB2, this will run perfectly on that. Well, hopefully perfectly. Okay, again, this is kind of an overview of what's going on with SQL Data Insights. We have our personas here on the left. So these might be people that would be calling SQL Data Insights or who are interested in what's going on. Somebody like a data engineer or a DBA or an app developer or a domain expert. This goes into ZOS. We're calling SQL Data Insights. Therefore, AI will be enabled. And inside of DB2, this SQL function is referencing your user data. And there is this model table that's created, that's generated when you train your data. And so that generated vector table, that DSN AIDB that we talked about earlier, looks like what's available in the top right corner. This like long string of positive and negative decimal numbers, which don't really make any sense to me. But when you're calling these queries, DB2 will make sense of what those numbers and values are. And this uses SIMD and uses zip. And then it will return this information that a business analyst might want to look at, or another application, or anyone like that to say, okay, hey, what is most similar? What can I do with this data? What is different? What is unique? What is an outlier? Okay, so here are a few screenshots of looking at the user interface for SQL Data Insights. This is from our lab and our workshop. So if you want to do this, let me know or let your IBM rep know, but it's relatively simplified. So this is going to be a very easy one when we're going through these screenshots for SQL Data Insights. So we're selecting what we want to focus on, and we're going to be looking at customer churn. And we're saying, okay, what out of what's available do we want to select? So we have customer ID, gender, senior citizens, and senior citizen, a lot of what we looked at that previous example. And we want to say, okay, Now we've specified this, we want to select this to train. We're training our data, we can enable that, and there you go. This will give you status updates on what each table is currently at, whether they've enabled or whether they need to be retrained or anything like that if they failed, giving you an indication of what's going on. And once they're being used, you can look at your data statistics that's available there. You can call a SQL data insight function in the user interface or in your own form of however you would call SQL against DB2. Okay, so that brings me to the end of SQL data insights for right now. And this last section here is intelligent performance enhancements that are available in DB2 version 13. So if you have gotten a DB2 version 13 workshop for your organization, some of this might look familiar. I was doing several of them when I was working in the WSC, and I actually still have a few in my new role. But these are bits and pieces of DB2 that have been updated to incorporate some deeper machine learning or AI, depending on how you define it, into DB2. And there's a lot of hidden insights in here. I can't even go through all of them within the scope of a presentation, but we'll give you a few examples. So the first one here, internal block fetch enhancement. This is available in functional 100 of version 13, but this is coming from running a query in DB2. So the data manager inside of DB2 would pass a query's result set in one row at a time to the relational data system in DB2. That is how it was originally defined and set up. And if you have a really large query and you're passing in a lot of rows, that gets really tedious and time consuming if you're doing that one row at a time. So in version 12, there was an update for doing an internal block fetch. So for a certain query, the data manager could then pass in a set of result set rows to a buffer that could then be retrieved by the relational data system. And that was really helpful saying, okay, if I have this query and I know that I'm going to be passing in a lot of rows, then I'll just go ahead and pass them in sets. So let's say a query is returning 1,000 rows. Once I get to row 100, then I can start passing them in sets of 100. So this happens because the query will hit a certain threshold. So a buffer will be used to hold a block of rows, but that will not be allocated until the number of rows fetched from this result set has exceeded an internal threshold. Whether that's 10 or 100 or 1,000, whatever it might be. So every time this query is run, it has to hit that threshold before it can be passing in sets of result rows. So there's a little bit of a delay of efficiency gain that's provided by this internal block fetch. So now we're doing an intelligent internal block fetch. So the intelligence piece is that DB2 will learn from when the query was run beforehand and saying, okay, the last time this query was run, we hit the threshold. We're noticing that this query is being run again. Let's just go ahead and automatically start with putting in sets of result rows instead of having to individually pass in rows until we hit that threshold. So it prevents that delay of efficiency gain, and it's intelligent because it's learning from what happened in the past and then will change behavior going forward. And so you then get this performance enhancement that's available in version 13 based off of an intelligent internal block fetch for returning rows from a query. There is a set of, we call them AI and DB2, again, a squishy term here, depending on how you define AI, which we talked about at the beginning, based on or for insert, update, and delete performance. This one is around indexes. So before version 13, there was an index look-aside that was based on catalog statistics, which were not really always up to date. And so if there was a decision being made in DB2 based off of this index look-aside, buffer, this index look-aside, and it wasn't up to date, then it would be getting old information. So in version 13, that index look-aside is now based on execution time information, which is as up to date as you pretty much can be. This is, let's say, near real-time execution time information. What was the most recent thing? What is happening right now? So this is the cache of the previous index probe. If you're a DB2 person and you're using fast reverse blocks, this can be used with or without them, just so you know. So this is bringing in that cache. That's a whole different conversation. But anyways, using this index look-aside based off of execution time information, this is that near real time, making it a little bit more intelligent. It results in 5 to 25% CPU savings for batch processing, or even 2 to 3% CPU savings for online transaction processing. So really this is, if you're running batch, you will probably see a much larger performance enhancement around this particular update. So sort optimization is the next category here. So before version 13, if any column was a dec float or a decimal floating point column, sort would not generate machine code to help move the data into a sort tree. So now it does, which is great. So now we're saying, okay, we have machine code that's being generated. That's kind of where that AI piece is coming in. And that will automatically start moving data into a sort tree to help get that sorted out overall, improving query performance. So that generating of machine language code, that is where we really see this performance enhancement that's available when we're doing a sort. There were a number of enhancements that were related to order by and group by in version 12 that were not applied to other areas of sort that we're now applying to other areas of sort, such as distinct, grouping, set, and percentile. So this is things like checking to see if the data is already sorted, making sure that the sort pool size is efficient based off of what we're giving it. And this is things like making sure we're looking at an internal work file, for example, and saying, okay, what are we actually looking at when we're doing this sort here? There's also more space efficient sorting for a list add within a substring. So if you're doing a list aggregation and you're calling a substring, then DB2 will now base that sizing off of really what you're taking out of both of those, since it's a list ag and you're doing a substring from it. So we're saying we can make the space more efficient. So DB2 is learning from those queries that are being run, learning from a list ag being called with a substring. Again, these are very small optimization enhancements that are available in DB2. The next one is added support, reducing the length of a long variable character or varchar value if it's at the end of keys to be sorted. So this is machine learning enabled. So saying, okay, we have looked at this in the past, we are learning from it, and now we're adjusting the sizing of these values to make it more efficient overall. So this is where this falls into that operational AI category, making things more efficient, more effective, more productive overall. And this third one here is sort L. So sort list or sort L in DB2. Version 12 had an APAR that was released that added support for sort L that came with the Z15, but it was pretty limited. Like, so the length of a sort key couldn't be over 136 bytes. The length of a records to be sorted could not exceed 256 bytes, which were pretty limiting in the scope of a sort L. So now in version 13, we've expanded sort L, and all of those sizing is now based on what the query actually is, which is great. So the use of sort L is driven by learned behavior based off of the number of rows that are processed, the size of the row, and the sort pool size. So there's less concern about those limitations of keys and of records. Okay, so this brings me pretty much to the end of what we've been covering. So what we talked about today was, well, we first started with what is DB2 and what is AI. Maybe you have a little bit better idea of different scopes of AI at the very least. We talked about DB2 AI on ZOS. So this included optimizing SQL, your SQL optimization. System assessment, how is your system performing and how could it be better? Distributed connection control is saying, okay, what work is coming in, what connections are coming in, and how do we protect the resources that are available? We talked about SQL data insights. Those are those SQL functions that have incorporated AI. So AI similarity, AI semantic cluster, and so on and so forth. I just listed all of them earlier. And now I can't say them when I'm on the spot. Anyways, those four ones. AI commonality, that's the other one. And then AI performance enhancements, we talked about those that are the updates that are available in version 13 to kind of incorporate and bring in AI into the behind the scenes part of your database. So thank you all for watching, and I can now check the chat for questions. Again, feel free to reach out to me with anything related to DB2 or data and AI on Z, and I will pass these slides to Amanda as well.
Thank you. While people come up with some questions, I have some posts and announcements to share. So hopefully I just did my screen share correctly. All right. Well, thank you again for that session. I'm really loving, like I said earlier, everything on AI and mainframe right now. It's just such an interesting time of things that are coming down the pipeline. So I appreciate you giving this session to us. I did want to share a couple of links. I will drop the links into chat. I know we have some fancy QR codes, but if you're like me, my QR code scanning abilities are limited. So here are the links that we're sharing here. As I mentioned, the Cheryl Watson tuning letter is available. It should be up now, actually. I think that it was supposed to go out to noon Eastern time, so that is live. There is also a recent post on IBM for DB2 and DB2 warehouse. And on the job board, I saw there is a post for a DB2 Z WSC database specialist. So a couple things to check out there. Then, as always, you can get involved by checking us out on social media. I think that LinkedIn is our most popular group, so that would be a great place for you to go and share your thoughts about how great the session was. Hi, Marcus. Share your thoughts there, and that's also a place where we post announcements if you're not already on our mailing list to get email announcements. And lastly, I'll just leave you with a save the date for July 15th for our next session. So with that, if there are no questions, we'll give it
I
a
see a few questions in the chat really quick. I think
okay.
maybe it was a direct
Yeah,
message. Yep.
I might not be seeing them on my end. Go ahead.
Yeah, so there was one question for system tuning, which I believe is from the DB2Z AI section. This person is asking, is that really a one and done proposition? So the classic IBM answer is it depends. If you have your system set up and it stays that way and you say, let's run a system tuning, a system assessment, and you get the enhancements and you change it, that's great. What I often see is customers will change their DB2 environment, especially as they upgrade or especially as they apply new function levels. And maybe they get new work, or if they want to add a DB2 data sharing member or take one away, for example, then you'll see a lot of their environment change. So it kind of depends on what you're doing with your DB2, on whether that's a one and done or an ongoing thing. And it also depends on your workload. The next question I have is AI semantic cluster assumes a known commonality among, does AI semantic cluster assume a known commonality among the entities? So my understanding of that question is there a certain piece of common information that that's looking at when you're looking at that particular SQL function? And that is kind of where that hidden insights of DB2 comes into play. So each of those, whether it's AI similarity, AI semantic cluster, AI commonality, that will kind of look at the data that's available and it will pull out things that might be obvious to us or might not be obvious to us. So I may be not getting your question correct, but the known commonality may not be known or as obvious depending on what your data is, at least to the people who are interacting with the data. And then I have one more question about internal block fetch. Where is internal block fetch intelligence stored? My first guess is that it is stored with the query, but I am not 100% sure on that one. So if you do want to follow up, we can follow up on that one just to make sure. And the lifespan of that info is that would probably be until either that DB2 member or your DB2 overall has been restarted. So it will maintain information as long as your DB2 is up and running within that section. But again, in terms of the intelligence, that is a follow-up that we can take offline. And I think that's all I have.
Great. Well, thanks again, everyone, for joining us today, and we'll catch you in a couple weeks.
Thank you, Amanda. Thanks, everyone.
Thanks. Bye.